Welcome to EC528 Cloud Computing Demo. We are Team Content Distribution Network with Web Application Firewall. In this video, I'm going to go through what a CDN is, our project significance, the design, the services, our project timeline, and then a video of our database schema, a user walkthrough, and a load balancing video. Finally, what we learned throughout the course of the project, the challenges we had, and future improvements to our project. The aim of our project is to build a content delivery network which differentiates from the existing provider. So what is a CDN? A CDN is a large distributed network of servers that accelerate the delivery of web content. The primary technique that a CDN uses to speed the delivery of web content to end users is to use caching. Content are stored in servers that are geographically closer to the end user, and therefore it can be pulled out faster. So why use a CDN? CDN reduces latency, accelerates the load time, reduces bandwidth and consumption of secure applications. Our project aims to offer a lower base cost compared to existing CDN by charging users only for the content they use, and we aim to implement a VSF or one-ish security firewall. Our project can be broken down into submodules, each consuming an instance on the MOC platform. First is the web server, which contains the fast application which handles all the user registration and CDN services registration. A DNS server, a data store, and one-ish cache servers which consume multiple instances.
Now let me go through with our project architecture. Our CDN system is basically divided into front-end and protected back-end service, these two parts. In front-end, we have our web application running on our web server, which we implement by using Flask framework. Clients will register and authenticate their identity via our web service portal and manipulate their CDN-hosted websites. Also, we have DNS interface to allow clients DNS queue request redirect into our customized DNS management service that we can implement our own load balancing algorithms. Besides, we have several cache servers running on, and we use a kind of web application accelerator, also known as caching HTTP reverse proxy called Varnish. We also deploy Varnish security firewall on those Varnish cache server, which can make our backend service protected. In backend, we have a data store component where our system database is running upon. Due to security concern, we separate the management component with the data store, so management can master the data flows and the control flows between our web server and cooperative cache service. Also, we have our DNS management as the backend implementation of the previous DNS interface we just mentioned. After illustrating our system architecture, let me clarify our whole system service procedure. How a client can use our system as their website CDN service. So, before using our system, a client has to have a website, say like abc.jtong.com, and this website has a record pointing to some IP address as the original server. This A record must be hosted at some authorized DNS service like Google's GoDaddy, and the clients has to register with our CDN to configure the abc.jtong.com to be hosted with CDN service. So in the UI customer config, they have to host their site name and original server accordingly as abc.jtong.com and www.jtong.com. And after that, our management portal will tell the customer the CNAME pointer to config for the hosted site name. That may be abc.hung.com.414d.me. After doing this, clients has to do these three operations. Clients has to add a record for www.jethung.com as its original IP. Customer has to delete a record for abc.jethung.com, and the client has to create a CNAME record for abc.jethung.com pointing to our abc.jethung.com.414d.me. And after this, the client has already registered our system service. So in our system, the registration with CDN management portal creates a database entry for that abc.jethung.com to track in the original server. And after that, we had to update the configuration of the varnished cache to know that they are hosting abc.jethung.com, and the original site for their name is www.jethung.com. So after that, we had to update our DNS server to know that its host name is abc.jethung.com, and it has a CNAME record of abc.jethung.com.414d.me. So the last step we do in our system is to update the DNS server to map the record of abc.jethung.com at 414d.me to the cache set 1 CDN.414d.me. The cache set is that we generate those varnish cache servers to one set, and we assign this cache set to this client.
Over the course of the project, we distributed the workload evenly among the sprints. For the first 3 sprints, we spent most of our time on understanding and design our project's infrastructure, set up instances in our mock platform, and provide some user interfaces to our customers. As for the last 2 sprints, we implemented the key features of the project, like redirect users' requests to our DNS server and cache servers, auto-scaling the cache servers, and implement the varnish firewall in our project.
We use PostgreSQL as our database. It is instantiated in the data store instance. As users sign up their service on our platform, their data is being tracked by the web server and stored in the data store. To use our service, the user would need to register an account in our platform. They would enter their username, their email, and password. Once the user registers an account, they have to sign up their service on our platform by entering the hostname and the origin hostname.
For the DNS part, we just implemented basic round-robin algorithm for DNS query. Like we have 3 varnish instances for this abcjhung.com, and every time we do dig command, which is the command that query the DNS record for this hostname, and it will return 3 individual varnish cache IP. And as you can see in the video, the round robin way just return one of the varnish cache instance IP, and it's the fair algorithm. What we're gonna do next is to upgrade this round robin algorithm into something like a priority queue. I think that's the optimal method for the load balancing. But for now, we just do the basic round robin way.
As you can see here, once the user registers their service on our platform, when an end user accesses the URL, they will be given the content that was stored in our cache server.
Now, let me briefly go through with our varnish security firewall part. As you can see, we now have 3 varnish caches running on, and they all have been installed with the varnish and the firewall. So we have in the firewall folder directory now. So, let me check the varnish status. As you can see, our varnish is already running on, and here we can say to our varnish folder directory, and we go to the default VCL. VCL is the varnish config language, which describe all the varnish configuration things. And in the first line, we can say we include the home Ubuntu VSF VCL, VSF.VCL. This is the config file for our varnish firewall, and we can see from here. Yeah, you can see that's the file. We define all the rules, like how we handle the HTTP attacks, like the cross-script attack or some security injection attack. All the rules are defined here. You can define some hotspot, honeypot, or some. Yeah, you can see all the actions, the rules are defined here. And actually, we should supposed to show the firewall log, but we have some issue about the log compaction. Since the log size is too huge, we cannot show the whole logs, and we don't know how to compact the log. When we do the whole log showing, our system will hang. So that's the reason we cannot do this. We show the log, but our firewall is actually running on and protect our backend service. Besides the VSF.VCL file, we got the handlers.VCL, which also like state all the rules to defend the firewall attack. We can briefly go through with this handler. Yeah, you can see like they define some rule trigger to detect those attacks and write them into logs. So this is basically 3 varnish firewall we have installed to our 3 caches.
Overall, we learned a lot from working on the project, from how a CDN works and what is the significance of having a CDN, and the problems that need to be solved with a CDN, and what other existed problems that are going on in the current market. And then we learn about how the cloud works by using the MOC platform, and then how to build and launch the project on the cloud. Moreover, we learned to use Scrum software development methodologies. Throughout the project, we faced many challenges, ranging from choice of technology, debugging, and researching. We spent a lot of time improving upon the technology we use, ranging from the web server and connecting all the different parts of the project together, while figuring out the next step of every sprint. We had minor difficulties working on the MOC platform, but overall, our problems were solved in the end. Future work of our project includes improving the DNS load balancing algorithm, which would significantly improve our performance if we would need to support large number of requests. Secondly, implementing MOC API scripts to analyze the load of each of the instances to determine how much loads and how much needs to be balanced. And then identify the actual geolocation of the origin server and the cache server so they are distributed more closer to the end user. And deploying cache server on other public clouds so our CDN covers a larger area. Improving the implementation of VSF and to compute a log of the attacks given, and then modularize the code in such a way that it could be used with other services like AWS.